calculation. I would like to introduce my teammates. I'm Juliet Najat, and my group mates are Lucy B and Nurhani Rafifa. For question 1 is the step of calculation of ordinary differential equation is the first order. They have three parts, which is part A, solving with initial condition. The question is solving using manuals by exploration of variable integration and applying the initial condition where y pi per 4 equal to 2. The simulation of MATLAB using the coding of DSolve is used to obtain the solution directly, where the result of this part, which is y equal to 2 sin 2x squared 1 over 2. The next part is linear equation solution, which is equation is rewrite in standard linear form and solve using the integration vector methods by using the manual calculation. And however, for the simulation symbolic solving in MATLAB with DSolve and initial condition, where y1 equal to 1, and the result for this calculation, which is y equal to x power of 6 minus x power of 5 plus 1 per x power of 4. In the next step of this, it is general solution, where the m integrate concerning x and adjust using n for the manual calculation. And however, for the simulation, use symbolic integration and simplification. For the result of this is ixy equal to c equal to y power of 2 minus xy. And the last step is apply initial condition where y2 equal to 3. And for the manual calculation in simulation, substitute values to solve for c equal to negative 9.
Okay, hi everyone. My name is Liu Zibin, matrix number AE240041. So today I will present and explain about our project, our ODE project, which is specifically on question 2. Let's go dive into the problem statement first. So question 2 is about the second order non-homogeneous ordinary differential equation as given as y double prime plus 2y prime is equals to negative y plus x squared minus 1. So we are going to calculate the general solution using both methods, two methods, which is the undetermined coefficient and the version of parameter. After finding and calculate the general solution, we are going to verify the manual calculation using the software MATLAB. Next, let's go to the manual calculation of the part A. So known as the sub question A, which is the using method of undetermined coefficient. So first of all, we are going to find the complementary function. We are going to first we need to identify which part is the homogeneous part, and we will equate it to 0. So the whole homogeneous part is the y double prime plus 2y prime plus y, and we will replace the m into y. We will replace the y into m, it will become m squared plus 2m plus 1 equals to 1, and then we will find the roots. And by referring to the table, the yc is equals to ae negative x plus bxe negative x. Why negative x is because the roots are negative 1. Next, we will go for finding the particular integral. For the particular integral is actually the non-homogeneous part for the original ODE. So it's at the x squared minus 1. So by referring back to the table also, yp is equals to cx squared minus dx plus e. And when we will going to differentiate the two times, we will obtain y prime and y double prime, which is the y prime is equals to 2cx minus d and y double prime is equals to 2c. After that, we will sub in, or known as plug in, all the equation of yp into the original ODE. So it will become 2c plus e plus 2d plus 4cx plus dx plus cx squared equals to x squared minus 1. So next, we will go for the next slide. So for the next slide, we are but going to equating the coefficient. For the x squared, we will get c equals to 1. And while we are equating coefficient of the x power of 1, we will get for c plus d equals to 0. We will sub in the c equals to 1, and then we will get d equals to negative 4. And when we are equating coefficient for x power of 0, we will get 2c plus e plus 2d and equals to 1. And then whilst plug in the d equals to negative 1 and c equals to 1, we will get e equals to 5. And therefore, the particular equation is x squared minus 4x plus 5. So the general solution will have a combination of yc, the complementary function, and the particular function. Yeah. And so the general solution is y equals the ae power of negative x plus bx power of bx e power of negative x plus x squared minus 4x plus 5. So next we'll go to the sub-question B. We're going to solve the sub-question B, which is using the variation of parameter. So for the variation of parameter, we need to identify the fx and also the a first. So what's the fx? Fx is the part where it's non-homogeneous. So based on the original equation, or the original ODE, the fx is equals to x squared minus 1, and the a is equals to 1. We have the a is located at the y prime. So same as the previous question, the m1 is equals to m2, so the complementary function is equals to ae power of negative x plus bx e power of negative x. So we're going to find the y1 and y2 also in order for us to plug in into the matrix form of the walk skin. So the y1 is equals to e power of negative x, y2 is equals to x e power of negative x. We just ignore the constant a and b. Okay, so the value of the wrong skin is equals to e power of negative 2x. Next, we are going to find the u and v. So by using the formula v and u, we plug in the value, the equation of the y1 fx a w for the v, and the u is the y2 fx a and w. So in order for us to find the value of v, we are going to apply 3 times the integration by part for the x squared, and 1 time for the ex, because it's a simpler integration. So at the end of the day, we will get v is equals to ex bracket x squared minus 2x plus 1 and plus b. So for u, we're going to apply integration by part 3 times for the x squared and 1 time for the ex. So at the end of the day, we will get u is equals to negative e power of x bracket x power of cube minus x squared plus 5x minus 5 plus 8. And then we are going to obtain the general solution by using the formula y is equals to u, y1 plus y2. By substituting all the value that we got, we will get the same thing as the previous answer, which is a power of negative x plus bx e power of negative x plus x squared minus 4x plus 5. Okay, next up we will going to show the simulation for this question. This is the program that we have completed for question 2. This is the program. So when we run the program, we will get the same thing which for the subquestion A, the method of undetermined coefficient. This is the general solution. So yeah, it's a general solution, but this is the computer language. So the asterisk means that for the same goes to for the racial parameter, we get the same thing, but it's in computer language.
Good day, everyone.
In this presentation, I will explain the differences between manual calculation and MATLAB simulation in solving ODE equations. Specifically based on question 3 of our assignment, each sub-question highlights how both methods approach the solution, and I'll explain the comparison for each. For question 3a, we were given a homogeneous second-order system using manual calculation. We first convert the system into matrix form and found the eigenvalues, and then derive the solution using Euler's identity. This process involved more theoretical understanding, especially in handling imaginary eigenvalues, and transform them into real value solution using sine and cosine. On the other hand, MATLAB allows us to perform these steps much faster. By using the each function and the symbolic computation, we obtain the same general solution with much less effort and higher accuracy. The main difference here is that manual calculation gives us a better grasp of mathematical concepts, while MATLAB speeds up the computation. In the question 3b, we deal with non-homogeneous system. Manually, we solve the homogeneous part first by finding the eigenvalues and eigenvectors. Then, we use the method of undetermined coefficient to assume a form for the particular solution, solve for unknown constants. After that, we combine both the general and particular solution and apply initial conditions to find the final answer. In MATLAB, the same approach was replicated symbolically. We use dissolve and solve to perform each steps, include solving for constants, and apply initial conditions. The difference here is that manual calculation involves more algebraic manipulation, which can be error-prone and time-consuming, while MATLAB handles the symbolic algebra automatically and produces results efficiently. For question 3c, we were asked to classify a first-order differential equation and check whether it is exact. Manually, we check the exactness by computing partial derivatives and integrate accordingly to find the general solution. We then substitute a specific point to find a constant value. And then for the MATLAB, this process was simplified and the code checked the exactness condition, performed the necessary integration, and gave us both the general solution and the constant with these few comments. The key difference is that the manual method reinforces understanding of the theory behind exact equations, while MATLAB provides a convenient and accurate tool to validate and solve the problem more efficiently. Thank you.